Just having trouble with the stream here, but we'll be good to go soon. Oh my god. Hey. All right, word up. How you doing, y'all? Pretty good. Pretty good. How's your weekend? Yeah. Did you like relax a little bit? Yeah. Did you go to the beach? No. So today we're gonna talk about SQL, the structured query language. You're gonna do a couple different things. It's all kind of centered around this idea of SQL, which you've done readings on over the course of the weekend, which is awesome. So some of the stuff that we're going to look at in lecture is just really going over that stuff again to make sure that you understand that and to kind of answer any questions that you have. First of all, has anybody here seen, there's this little known indie film series called Harry Potter? It's so good. It is so good. Have y'all like watched the Harry Potter movies recently? Dude, those things hold up so well. I have genuinely been watching like the Harry Potter movies that are on Netflix while working, and I'm getting wrapped up in it all over again. So I don't know. I think I'll be coming out with a series of Harry Potter themed lectures in the next little while, because genuinely so good. I mean, those movies are dark and gritty. Yeah. Looks like that's what we're using at some point. Let's see, Nerds API. Like this one? No. Yeah. Yeah, send it to me because I'll use that for a lecture then. But no, like legit public service announcement. If you haven't watched the Harry Potter movies recently, years 5, 6, and 7 are on Netflix right now. Yeah, Kelly, you got me back into Harry Potter. Hey, Vicky. Yeah. Oh, they're so good. Like so good. Um, I mean, they're funny, they're scary, they're a little emotionally just kind of like ooh. I saw some pretty big plot points yesterday. So, anyways, I'm still like riding that wave. Yeah, spent some good amount of time on the Harry Potter Wikipedia page. Anyways, yeah, public service announcement. So today, what we're doing, first of all, I'm just gonna put homework. Watch Harry Potter. Today, what we're doing is we're talking about the structured query language. Structured query language. SQL for short. Now, I'm going to preface the conversation about how to actually deal with SQL by just kind of motivating the idea a little bit and going over some of the stuff that you did last week. So last week you did some stuff with persistence of data. And who did that lecture for y'all? There's a lecture called Data Persistence, or State Management and Data Persistence. Joel, cool. So week 3, day 4. And what did you learn about persistence of data? Can you give the Cliff's Notes? Right, so it's important if the server restarts. Cool. Right? Now, when I teach the data persistence lecture, because it's on Mongo, right? I kind of frame it around 2 things. One of them is, yes, if the server restarts, we still want our data there. But we also want, like, smart interactions with our data set, right? I want to be able to ask for particular things. And with Mongo, it's not like you're not able to do that necessarily. You did that in Twitter. You have something to the tune of, DB whatever tweets select, or what is it? It's like find, and then you have to pass in the ID of the tweets, or something like find all the tweets or whatever, right? Mongo has its own syntax for asking for particular pieces of data from the database. And it's kind of centered around the fact that Mongo is what we're going to call like a NoSQL database, a NoSQL, right? NoSQL database, right? Now, Mongo is built around the structure of having like documents. In fact, Mongo might even be called a document store, right? Like that's just another word for the kind of database that this is. So Mongo has, if we were to look at the structure, it has a bunch of databases. Like say I was to pop into Mongo. No, whoops, Vagrant SSH. Say I was to pop into Mongo and use the Mongo shell. I don't think I have a ton in there right now, but let's see, Mongo use or show DBs. There's some databases, and then inside of a database there are collections, and then inside of a collection there are documents. That's the hierarchy in Mongo. So just to write that down, there's databases, then there's collections, and then there's documents. And there isn't a particular structure to how you have to put stuff or how you have to put documents into these collections. You can just really throw things in willy-nilly, right? As an example, here's an example collection. Oh my god. Boop. Like here's an example collection. It's going to be called dogs, right? This isn't real syntax. I'm just trying to show you like hierarchy. I might have a dogs collection, and in here I might have Frida, right? And Frida might have some information like social insurance number, favorite Netflix show, best friend, like all sorts of info. And then I might have another dog in here like Solomon, and Solomon might have a whole bunch of other information, right? And here's my passport ID number or whatever, right? And then maybe Solomon has an HBO show that they like, right? Just something completely different. And maybe instead of best friend, here I have food. And this is like an array with a bunch of foods, like what do dogs eat? Potatoes, kibble, right? Just a bunch of info. But what I'm trying to show here is that I've got Solomon and Frida. They both live inside of the dogs collection, right? But they have a bunch of different information, not just value-wise, but also just the context of what it is, right? This here, Frida has a best friend, and Solomon doesn't have a best friend in here. Solomon instead has some food, and Frida doesn't have any food, right? Frida has a Netflix show. Solomon has an HBO show, right? Completely different things, right? So Mongo, we'll say it's unstructured, which is good for some reasons, and it's also bad for some other reasons, right? One of the reasons that it's good is that I can treat Mongo just like I can treat Mongo the way most people growing up treat their bedrooms, right? Just like, just toss more stuff in there, right? Just, right? That's what Mongo is, and it's totally fine. You're like, Mom, I got a system, right? You don't understand. I have a system, right? That's what Mongo is. Right? It doesn't actually have any rules, but it's up to you to decide what those rules are. Right? I'm genuinely gonna write that down. That resonated with you there. Right? Yeah, Mom, I have a system. That's Mongo, right? And it's totally fine. Maybe when you're spinning up a project really quick and you just don't want to spend a ton of time thinking about what the structure of your data is supposed to look like, you're like, whatever, I'll just toss it in as I kind of see fit. I want to be adaptable. That's cool. Now, we run into issues here when then, say I have a bunch of dogs, and I ask you to give me a list of all of the favorite foods of all of the dogs, right? With Mongo, I might write a query that says something to the tune of go into the dogs collection, right, and return all the dogs' foods. Let me turn that off right there. That's annoying. Go into the dogs collection and return all of the dogs' foods. And, maybe this is fine for Solomon, but it's not fine for Frida, right? What should Frida return, right? Frida might return undefined or something to that tune, right? Or maybe it throws an error. I don't know. Right? But we just run into that issue where, like, all of a sudden, maybe I have some part of my functionality, like maybe this is dog book, my website, and I need to be able to show people, like, dogs' favorite food. Now I've got this issue here. Right, return all the dogs' foods. What about Frida? Well, that's one thing. Like, maybe the data that I'm looking for just isn't there, right? Here's another thing. Maybe for Frida, I've put social insurance number, and Solomon here, I've gone government info, and then in here I've put info. In here I've put passport ID number, right? And maybe I've also put like social insurance number here too as well. I've just structured these two dogs differently now completely, right? Frida has a social insurance number at the top level here. Solomon still has a social insurance number, but it's just structured somewhere else, right? Now I've put myself in a pickle. Because maybe at some point while I was working on my project, on my thing, I decided I just wanted to change like the actual structure of how this stuff gets represented in my database, in my Mongo. I played myself again, right? Now maybe I'll have to write a script that goes through all of the dogs and ensures that everybody's got a government info, right? So that whole like mom, I have a system, like it's on you to impose that system at some point. So being sure that you don't end up changing that system, right, and messing things up for yourself. So this is Mongo. It's fine. It's okay. But it leaves for me, it leaves a bit too much room for human error, right? It leaves a little bit too much like flexibility, right? I like in some cases my tools to be really inflexible, and I like them to have like really strict opinions on how I should do things, because then there's a right answer, right? If I'm talking about Mongo and you ask me like, oh, like how am I supposed to structure this thing? My answer to that is I have no idea. You could just kind of do whatever. It's your room, you do whatever you want. And it would be nicer to have like a specific set of rules and a specific structure to what we want to have here. So specific structure to our data. So enter a whole like brand of databases called relational databases. Relational databases are going to fix some of the issues that we're talking about here. And they'll also allow us to do things like, say I had a collection of owners, right? And I might have like, Nima under dogs has maybe Solomon, right? I also own Frida now. I know. So, like, I would like to be able to say something like, hey, get me all of Nima's dogs. In Mongo, I might have to make a collection like this where I say Nima, dogs, Solomon, and write that stuff down. And then I might even want to say, hey, from the dogs, find me the owner. Now I'm going to need to go under Solomon and do something like owner Nima. Right? again, I want to stress that what I'm doing right now, like this isn't real code. This is me just trying to show you relationships between objects, right? Oops. So when we're talking about relations, this is what we mean. There might be one owner that has a dog, or one owner that might have, many dogs. Right? And we'd like some way to kind of structure this up. So relational databases specifically use SQL, SQL, or SQL. And these are things called RDBMS. So RDBMS stands for Relational Database Management System. And we're going to unpack this in a minute. What we're going to do before we start unpacking is do a little bit of whiteboarding. So let's see. Erase everything. Can somebody just help me align this real quick? Thanks, dude. All right. Is this fairly visible for everyone? All right. I'm gonna. Oops. I'm gonna draw some shapes, and I'm gonna try to stump you. Let's see. Let's see if you can tell me what shape this is. Ooh, is it safe for me to delete this or erase it? I don't care. Hot tip: don't leave anything on whiteboards, because I'm drawn to erasing whiteboards. Okay, so can I just verify that people can see? No, wow, oh my god, that's really bad. That is the letter. I have bad news. Yeah, it is the letter C. Yeah, no, okay, sweet. So it's the letter A. All right, let's pick an app that we want to build. Let's just build something. The one we have in the notes is a kind of an idea, is making a website where people answer quiz questions. So there's like lots of quizzes and people can answer questions or whatever. And we can totally do that unless there's something else you want to build. For example, is there like a midterm project that you want to build that you can formulate as a question and I can show you how to build it? Don't actually do that, but what should we make? Let's pick a noun. What's your favorite noun? Okay, what did people have this morning for breakfast? Did you all have breakfast? Coffee. Cool. All right. So we're going to do coffee. This is coffee DB. Okay. So as we're talking about coffee, I'm going to think about this as maybe a website with all sorts of coffee information and where to find particular coffee and where were those beans roasted and where were those beans harvested and all that stuff. Who's the particular barista that baristaed those, like that coffee or whatever, right? All sorts of stuff. Now, in order to really begin anywhere on this whiteboard, I need to come up with a couple kind of situations for myself. So I'm just going to write them up here because I don't want to face away from you for too long and just type. That just feels boring. So, Coffee DB. This is the world's premier site for learning more about your coffee and coffee possibilities. So, let's say, for example, there are many different kinds of coffee beans. Am I wrong about that? No? Different coffee beans. All sorts of different coffee beans, and I might want to be able to see information about these different beans. So different coffee beans, there's different locations for where those coffee beans are from. There's different coffee shops, right? Different cafes around my city. Let's see, there's different people at the coffee shops, and we'll say there's different drinks that I can get at each coffee shop, right? And let's see. Let's also say that each drink has a price, not as in like your firstborn or something. Like not like it has a price, more like it has it has money. So a bunch of information, different coffee beans, different locations, different coffee shops, different people, different drinks, different prices. Something that I want you to note from this is that I'm listing out like a bunch of nouns, right? All the nouns that have to do with this thing that I'm building. Just imagine I have a website where I can put in how much money I want to spend, right? And which barista I like, and it'll show me what drinks I can have at the coffee shop where that barista is at, or whatever, right? I'm imagining a place where baristas are like tattoo artists. What's that? Archie, what's up? Where you have to have like an appointment with the barista to get like a particular, like, I've been on the wait list for this cappuccino for 4 months, right? Like that's the situation that I'm just kind of setting up here. Now we've got these different nouns. Did I say beans? There's location. This is location like country or whatever, like the country that the beans are like beaned in. Shops. People who make coffee. Drinks. And then cost or price. Okay, just a bunch of words randomly assorted out onto this thing, and now what I'm going to do is start drawing lines. Beans come from a particular location. There you go. Got a little bit of a connection there, a little bit of a relationship. Beans are used in drinks, right? Beans are used in drinks. So now I could go, oh, if I have a drink, I could find the beans that are used for that drink, and then from those beans I can find the location that those beans were made. Right? I don't have any of this code. I don't have any of this actual data, but just this is the structure of the data that I'm building up. Drinks are a particular price, right? Drinks are a particular price. Drinks are also served at particular shops. And people are made out of beans. No, people are people work at shops, right? And right, but do you see the structure that I'm kind of building up here, right? Now, conceivably, if I was to give you a person, Bradlina, it's a real name. If I have a person, right, you could tell me the shop that person works at, right, the coffee shop that person works at. You could even tell me the beans they get used at the shop where Bradlina works at, right? This is why this stuff is cool, right? Because I can have a whole bunch of data. I can have a whole list of beans, a whole list of locations, shops, drinks, people, price, right? But I can do interesting things with it, right? Your applications, you're going to have a lecture on this soon. Your applications are really just a window into the data that you have, right? Web dev is all about, here's some data, here's how you can look at it and do something useful with it, right? That's all that web dev really is, right? Otherwise, like YouTube, you would just like access it through the command line, right? Just like type in the URL of the videos that you have to see. No, there's a search bar. I can type things and it shows me stuff. Facebook, same thing. I need to be able to like search for my friends. I need to maybe be able to search for events that my friends are going to, right? Our life on the web, really anything useful has to do with these relationships and connecting things together, right? This is a good exercise to do, by the way, right? I really recommend taking some time, come up with a noun, come up with a hypothetical website, right? Make a little bit of database here, right? So I've got my location, beans, shops, drinks, price, people. Now, we can get a little bit funkier, right? Instead of drawing just straight lines through this, I can do things like say, hey, beans might come from like one location, right? But there might be like a location that makes many different kinds of beans, right? Or in my hypothetical scenario here, people are only allowed to work at one coffee shop for right now, right? We'll maybe get funkier in a sec. So people, shops, like shops might have, oh my god, my pen died on me. Shops might have many people. I'm doing this little crow's foot situation, just like whoosh, right? Shops might have many people, right? Drinks. A shop might serve many drinks, right? We're going to say that for right now, a drink is going to be made up of like one bean. I know that it's not coffee, but do you see the kind of relationship that I'm trying to draw here? And then prices, for right now, I'm going to say every drink has just one price, right? Maybe it just has one price, but something that we might explore is something like, actually, you could do this now. Sure, a drink has one price, but what if I connected to shops not through drinks, but rather, oh my god, my pen died. Any pens over there? Oh, is this not? Are there people who don't like this? Because I can. Oh, okay. Because I can totally like we could change gears anytime. But what I was trying to show here is the more I think about it, the more I say, hey, Starbucks might offer a drink at one price, right? And then Waves might offer a drink at a different price, and then my local like artsy shop might offer that drink at like 3 times the price because it's made by whatever, right? Like there's all these different prices. So maybe instead of drinks connecting directly to shops, I might do that. There's like a drink, like a drink shop offering. This pen's almost even worse. Through which I can connect to shops, right? This way I've built up what I'll call like a many-to-many relationship. Right? I'll say that there can be many drinks and many shops, right? Like a shop might have many drinks, and a drink might be offered at many shops, right? And I've built something in between that connects the drinks and the shops, right? So there might be a cappuccino offered at Starbucks, and there might be a cappuccino offered at Waves. And if I put the cappuccino offered at Starbucks and cappuccino offered at Waves information in here, right? I can have one nice place where I can keep track of all the different drinks that are offered at one place, right? We're going to iterate over this idea a couple times, right? So if it feels like I'm zooming through this, it's because I am, right? Now, at each of these places, I'll want to say that there has to be particular information, right? Unlike what we did with the dogs, right? I'm going to say that beans have to have particular info. Beans have to have a flavor profile. And beans have to have this is so bad. Beans have to have like a roastness. Oh, one of these is good. Whew. Okay. Beans have to have like a profile. Beans have to have like a roastness. Like roast, the light roast, dark roast, all that. Shops have to have an address, maybe, right? People maybe have to have a name, right? I'm saying this stuff that needs to exist, and I might even say that like drinks need to have a bean that they're made with, right? So I'm forcing that connection, and I could say that it needs to have this thing, right? And I would like to have a way to describe that in the structure of the database as I'm building it. Because right now all I'm doing is I'm just drawing out lines. What you're going to do in a minute is kind of start turning this into actual code. Right? This thing here, I know I glossed over this. We're going to talk about that a little bit more. Right? Don't worry. Right? For right now, focus on this stuff here. Right? Saying that there's particular entities. Right? Particular entities being the nouns. And they have particular relationships. Right? A location is related to beans. Now, a database is really, or a relational database is really just a series of lists, right? A series of lists. I'm just keeping track of information row by row by row by row, right? And each one of those rows, I can say can have particular information, right? Unlike Mongo, again, where I can just toss in whatever, right? An SQL database or a relational database is going to have these rows, or I'll say for beans, it might have every bean should have a name, every bean should have a roastness, every bean should have like a profile, like a taste profile or whatever, right? And then I might also say that every bean has some unique identifier, right? Every bean might have like a number associated with it, right? Beans. I might say the same thing about drinks. Drinks should have a name. Drinks should have, what else do drinks have? Foam, syrup, all sorts of information. And then something that the drinks should have is also the particular beans that they're made with, right? I'm going to say for right now, every drink is made with one type of bean. Now, I could 100% also just write all the bean info in here. Right? Meaning I could have a column, or I could in this thing here write about the bean profile, bean roastness, the bean name. Right? I could write all that information and have that both here and written out here. And we go, hot dog, awesome. I'm looking at my drinks. I can look at the name, the foam, the syrup, and I could also look at the bean profile all in one nice place. Beautiful. But we run into an issue. We run into an issue because say somebody changes like the bean profile, right? Somebody goes ahead and says, oh, you know what? It's not a front-facing, whatever. I don't know how taste profiles work. But do you know what I mean? Someone's like, this is actually more chestnutty than apricot or whatever, right? And then so somebody goes into the beans over here and edits that. If I've copied that information over here, right, now I'm going to need to go over into here and edit that as well. Do you see what I mean? Right? And say that there's many drinks made with that bean. Now I'm going to have to go to all of the drinks that are made with that bean and edit that all over, right? Instead, it would be nice for us to not have all of the bean information here, but instead say, hey, here's the ID of the bean that's used. If you want to find more info about this bean, go there. Right? If you want to find more info about this bean, go there. And what we're talking about here is an idea called normalization. Right? So this is a word that's going to pop up in your career as database people, right? You will use databases, whether or not you're front or back end. Like, I guarantee that even if you're a front end dev, there's going to be like a week where it's like, our back end dev is sick. You need to come do this thing or whatever. You need to know a little bit about this. Right? Database normalization means pulling out any information that might be repeated multiple times, right? And putting it into its own table. Right? So each of these little nouns that I've made, these things, I'm going to start calling them tables. Okay, I'm going to start calling them tables. So instead of having all the information for one particular bean right here, I'm just going to say when you want to see that bean, go over there. Okay? And what we'll want is a language that allows us to easily make that jump. Okay? Easily make that jump. Is this idea kind of making sense? Right? I want to spend as much time as possible on the conceptual stuff, right, in this first half, and then we're going to dive into actually writing the code. But again, I want to stress that I think it's really, really worthwhile spending as much time on this when you hop into a project as opposed to writing code. Right? So something that like all of y'all are going to do, because my prior experience tells me this, is that y'all are going to get really excited and just start writing code when you start your midterm projects, right? Which are this week. Same thing's going to go, on with your final projects, is people just dive right into it. But it is paramount. Like, it is so important that you whiteboard this stuff out and think of all the things that you might want to be able to do, right? So I might ask myself questions like, on my website, I want to find all of the, like I said, all of the countries that the beans that Bradlina works with, like all of the countries that those beans come from, right? And then I can base my data structure around this. This thing here, we're encroaching on what's called an ERD, or an entity relationship diagram, right? I've done it in a little bit of a devil may care kind of way, right? We're going to look at a more structured one in a minute, right? An entity relationship diagram. And this is what's going to inform what I'll call your schema, right? And your schema is your formal actual definition of the structure of your data, right? I also want to make a note here where we're going to talk about duplication a bit more in a minute. Okay. Are there any questions at the moment? Sweet. Okay. So, moving back to this thing over here. What time is it? It's 9:41. So, what I'm going to do is show you a picture of an actual ERD that looks pretty. Here's an ERD of a database that we're actually going to be working with in a second. So this is like a music database, right? Immediately I'm drawn to the nouns, artists, tracks, albums, tags, artist tags. Right? So artists, an artist might have an ID and a name. Tracks might have an ID, an artist ID, an album ID, a number, and a title. So the artist ID refers to this other list over here of artists, right? Now, I think of this stuff as having multiple books. It's having like multiple phone books that I'm reading through, right? So I might have a book of artists and a book of tracks, right? Thinking like they're actually separate things. And as I look through the book of tracks, when I find a track, it'll say ID, artist ID, album ID, number, title. And if I want to find information about the artist, I need to go to the artist books, open this up, and find the artist with that ID. Right? I have these things split up into actual separate things, separate lists, separate tables, number and title. And then I have albums over here. And now they have this kind of relationship here where I have a track has maybe one artist. An artist might have many different tracks that could exist. Right? So a track has one artist ID. But it's not beyond possibility that there's multiple tracks with the same artist ID. Right? That's not beyond like the realm of possibility. Same thing here. An album in this case is going to be made of like one artist ID. But it's not beyond the realm of possibility that an artist might have many albums, so many albums with the same artist ID, right? So this is the kind of thing that I want you to build when you start working on a project. Before you write any code, right? You should hop into something like, there's a website called draw.io, right? Draw.io, and what you can do on a website like this is start dragging and dropping little boxes, put some text in it, and say, oh, this is my, coffee bean. What would you call it? Bean. This is a bean, and here's a drink, and these beans and the drinks are connected by that way, like this, something to this tune. Right now, something that you'll notice when you're looking at, bless you, something that you'll notice when you're looking at something like this. Where'd you go? Where'd you go? There you go. Something like this is that there's like a convention for how we make these diagrams that I suggest you stick to pretty strictly. First of all is that the names of these tables, as we're going to call them, the names of the tables are written in lowercase, in plural. They're always nouns, they're always lowercase, and they're always plural, right? Artists. If it needs to be 2 words or multiple, we'll separate them with an underscore, right? Always. If you're using like a relational database, right? Why do we want to do this way? Well, there's other programs that are made to interact with our databases, and they work nicely if we follow the standard for naming. You're going to learn more about this in week 7, right? Tags, tracks, albums. The other thing that you might notice is that there's a structure for how these IDs are done, right? So every one of these tables is going to have ID, except for where maybe we really don't need to be able to identify a particular thing. Right? So if I need to be able to identify a thing, like an artist is a thing that I might actually use a lot in my program, right? Like I want to be able to see an artist's page, or a particular track. Like I might want to be able to select a particular track, right? These things are pretty important, so I'll make sure that they have an identifier. Something like artists tags, these are all the tags that an artist has been tagged with. So maybe an artist has been tagged as rock and has been tagged as pop or whatever, like all these things. That particular tagging might not be very important. Like I might not want to have a page on my website where I can see the one instance when Kanye West was tagged as rap, right? I might, but like I can't think of a case where I might need that, so maybe I don't give it an ID. Right? But anything that's particularly important to be able to see as one thing, I'll give it an ID. The other thing is, when I am referring to another table, it'll be written as singular underscore ID. Right? So here, I have artists, and I have tracks, and I say that my track is related to an artist. I will go artist underscore ID, and that's the convention, right? Singular underscore ID. And what we're doing here is we're registering what's called a foreign key, right? So artists ID, this thing here is called a primary key, right? The primary key is one value that can be used to identify that particular resource, right? To identify that particular thing. When that key is used in that table here, like right there, it's called the primary key. When I use it somewhere else to make a reference to that particular resource, it's called a foreign key. Right? And this is something I'm going to say again when we come back from the break, is that if I want to make a one to many relationship, meaning one artist can have many tracks, right? The foreign key goes on the many side, right? The foreign key goes on the table that holds the many things, right? Foreign key goes on the many side. In fact, if we look at Carl's notes, he even has a nice little picture. It says the foreign key is on the many side. And it's got these cute little people on it. Right? The foreign key goes on the many side. Right? Now, I'm going to start off thinking about all my keys, my ID and whatever, right? I draw my little bubbles, right? I start just connecting the lines here and there, right? And then eventually when I figure out, okay, beans and drinks, like maybe a drink is made with one bean, I'll just have bean ID. A drink is made with one bean, but beans might be used for many drinks. So one to many, foreign key goes on the many side. Are there any questions about this? Now, something that you're going to notice here in the picture that I have up is that there is a relationship in here that is many to many. Can anybody spot it? That involves 3 tables, which is why it's weird. Yes. Mm-hmm. Yeah, right. So here in artist tags, we're connecting artists and tags because there might be a tag that's used on many artists, right? Drake might be hip hop and Kanye might be hip hop, you know, one tag being used for many things on the other side. So if we go, oh, the foreign key has to be on the many side, right? If it's one tag used for many people, then sure, let's put the tag on the people. The ID on the people, the foreign key. But then I might say there's an artist that has many tags associated with it, right? You know, Kanye might be put as hip hop and also pop rap. Well, now if I say the many side has to have the keys, then I need to put it on the tag side, but I've already put it on the artist side, and now this is just weird, right? So instead what we do is we merge that information in one table called a join table, right? This is a table that's going to connect 2 things. So now here I have one to many, one to many, de facto having created a many to many relationship, right? We're going to see this on the whiteboard in a minute. Now, are there any questions? Cool, so the language SQL is built around making this stuff work properly, right? That's what it's going to be built around. We'll take how's a 10-minute break sound? Sound good? Sweet, so at like 10:12, 10:13, we'll pick up again. I got that wrong. 10:02, 10:03. That would have accidentally been a 20-minute break, which is fine, I guess, but cool. All right, welcome back, everyone. Gonna start this off with another PSA. Anybody here into like road cycling? Any road cyclists in the crowd? Wait, actually? Man, okay, the weather's like really nice, so I'm looking for people to go cycling with. If by any chance you decide to buy yourself a road bike and want to go cycling, let me know. Also, the Pacific Populaire, again, if you decide that you're into road cycling, is happening. And it's this fun ride around UBC, and then we do a loop of Richmond. So if anybody wants to, again, buy a bike and do 100K, no, is that a slow nod? Is that what that is? That's a neat sideways nod. I've never seen that before. Yeah. So damn. Anyways, if you got any friends, it's just cycling on your own or cycling in groups of like 2 or 3 feels really dangerous. And scary. So I like cycling in big groups. As well as like you get into like a line, and when you're in like formation, it's like, okay, bikers, let's get in formation. You know, like that kind of. Yeah. So no, yeah. So it feels really cool, like in full on spandex and all that. Anyways, when we left off, we'd done our little coffee database. And we've done this thing, and I hadn't said this, but I was thinking something to the tune of, if this thing is called a table, this is a table, and it has all these things. If only there was a way to say, create a table with these things. Oh, if only there was a way, right? There is. Behold, right? Create table, artists, right? In our case, it might be something more to the tune of, let's just do that here. Create table, what's that up there? Beans? Right, so plural, beans. You know, ID. This thing here, genuinely just copy this line and paste it everywhere, right? This first line here is the first column in the beans table, right? I see you, James. Yeah. The first column in the beans table is saying, hey, the first column is called ID, right? It's the primary key, and the type of thing that it is serial, right? Serial is going to mean like an ID number that's going to get generated by the database system that we're using. So ID is the primary key in this table. It's not allowed to be empty. And that's it. Here's the next line. The next column is called name. Name is a varchar. This means string, right? This is a string of 50 characters. And it's not allowed to be null. And say I wanted to add other things. What was the other stuff that I had in here? The roastiness and profile. So roast might also be varchar, maybe. Not null. And maybe I'll do the same thing for... Maybe I'll do the same thing with the taste profile for the moment. I'm going to 100% right now ignore the fact that beans is connected to location. Right? Let's just ignore that for a second. We're going to work on this side, like drinks and beans. Because I might do the same thing over here with drinks. And drinks has... what did drinks have? Okay, name, foam, and syrup. Okay. I'm going to keep maybe foam as a yes or no. So there's a Boolean value. I'm going to look up SQL, Boolean. Right. Is there a Boolean type? Is there a Boolean type? Yeah, Boolean. So we could say syrup is a Boolean Syrup is a Boolean, and it's not allowed to be null. And maybe, oh wait, foam was supposed to be Boolean, my bad. Syrup is just going to be a varchar 50, where you will just say what kind of syrup it is or something. But the other thing that it had in there was that bean ID, right? Had that like bean ID. And we want to be able to say something like the bean ID, it refers to the bean in the beans table. Right? I want to be able to say that. The bean ID here, it's referring to that other thing. Right? So that my database system is able to know that. Right? I could just straight up just say bean ID is supposed to be some cereal. Right? Just like this, and just leave it up to chance. But what I'm going to do instead is I'm going to say something to the tune of this. That the bean ID references the ID of a bean. Right? Notice that like I do a lot of copying and pasting when I write my SQL. That's totally fine. You're gonna be writing some things called queries. And queries are like questions, right? Like I'm asking for stuff. And as these queries get more and more complicated, for me, they become more and more hard to like really understand. This is not an SQL bootcamp, right? This bootcamp is about building web applications. So you shouldn't feel bad about patching together different things. I do want you to understand what you're writing though, right? It's just don't feel bad if you can't like remember the stuff off the top of your head. So say that like the bean ID is, and let me just check on this thing real quick. One sec. Yeah. Okay. So serial is just an integer that gets generated randomly by, or not randomly, like it gets generated by the database as it's inserting stuff into it. I've used that word insert, and we're going to talk about that a little bit. But it's going to be like a number. So if I want to make a reference, I can say that the bean ID in drinks is an integer. The reference is bean. I'm going to get rid of this next part here real quick. I'm just going to leave it at this. All right, we'll talk about the thing that I deleted in a couple minutes. And now what I've done is I've created two lists. I've created beans and I've created drinks, right, as a structure. Now, moving forward, I'm going to be using two databases that I already have built, right? So I did, like, I just learned today that we were going to do coffee, so I don't have a coffee database. But what I do have is a music database, and I'm going to have a database of students that we're going to play around with as well. So shifting gears from coffee to instead music, the database that we're working with looks very much like this, right? This is the database. So it's going to have artists, tracks, albums, artist tags, and tags. And here we go. The lines at the top of this, because we're looking at what's called a script, right? This script is meant to be run, right, like a program. The first lines here say, if the table already exists, drop it, right? Because we're going to go ahead and create. So the word drop means to like delete that table. So we're going to create some artists and they have some things. We're going to create some albums and they have some other things. Right? Some tracks, some tags. What I want you to notice from here are that you can define these relationships, right, by defining the foreign keys that are used in particular tables. But the other thing is that we're defining the types of things. Saying, for example, a title has to be a string, right? Like we have to say that thing, or track ID has to be an integer. Count has to be an integer. We're saying those types, and that's kind of new to us because in Mongo we didn't really have to do that, right? In Mongo we could just, have a system, right? I can just throw whatever I want in there. It's fine. So, so that's something that you're gonna have to get used to, right? SQL is a new language, right? It's a completely new language for you, right? So it's gonna feel a little bit awkward. You can get okay with it. Now, before we look at the rest of what's going on in here with insert and whatever, so we're just seeing create table. I want to go back to what I'd said. I'd called the thing an RDBMS, a relational database management system. It's important for us to understand that there are many different kinds of relational databases, right? Or rather, many different relational databases out there. There's Postgres, or PostgreSQL, the world's most advanced open source database, right? There is MariaDB, right? MariaDB. There is what else is there? I think Oracle. That's a database. Oracle database. All these different databases. Microsoft SQL Server, right? Another relational database management system, right? These are all different programs, right? They're software that runs on your computer, just like a browser. How a browser runs on your computer, you can have many of these different databases installed on your computer, just like you can have many different browsers. Now, these databases all work or behave in similar ways, right? All these relational databases, like Microsoft SQL Server is going to behave similarly to Postgres, right? PostgreSQL. They're going to behave similarly. Just like how Chrome and Firefox behave similarly. They're used for the same thing, right? But in some cases, one is better than another for really specific things, right? At the core of it, with a browser, we can communicate with our browser using HTML, CSS, and JavaScript, right? And even though like the implementation of the stuff inside of the browser, like the way that it understands JavaScript, might be coded differently in Chrome versus Firefox, we as the developers, we use JavaScript and talk to the browser that way, right? The exact same idea is with these relational databases, right? They're programs that live on your computer, and you can talk to them using a language called SQL, right? So SQL is a super old language, 1974. Pretty, like, as far as languages go, it's up there, right? It's a strong language, and it's really general in terms of it's made so that it can work with all these different SQL-ish databases. So just because we're working with Postgres doesn't mean that you can't take what we've learned and translate it over to SQL Server, which is another database, right? So when people say database management system, right, it's the actual program that is doing the database work, and it listens for SQL. So you have in your Vagrant, you have Postgres. You can access Postgres with PSQL, and I think you did this over the weekend, correct? Am I wrong? Didn't do it. Awesome. PSQL is your command line interface to Postgres, right? Just like how you were writing Mongo to connect to Mongo, to connect to Postgres, you're going to go PSQL. And this is going to put you in a place. It's going to put you in a place that looks a little bit like this. Okay? Similar to Mongo, but I can't go show DBs. Right? That doesn't work. I can't go show collections. That doesn't work. Right? That doesn't do what I'm trying to do. Instead, what we have to do is write SQL queries. Right? We have to write lines of SQL. Now, all of the particular database management systems like Postgres or SQL Server or Maria, they're going to have their own little, like they use SQL, and then they have a couple extra commands. Right? For example, an example of an extra command in PSQL is a command to list all of the databases that are currently on my system. \L. Right? So \L, this isn't SQL, this is Postgres. Right? It prints out a list of all of the databases that are on my system. I have a bootcamp database, a music, a Postgres, a template, Vagrant, all this stuff. By default, your Postgres is going to have it's going to have at least one database in there named with your username. Your username is Vagrant when you use Vagrant, but say you were using Postgres on your local machine, it would be your local username. Now, in the same way that Mongo had that structure of databases, collections, documents, right? Postgres is going to have databases, tables, and then records, right? And a record is going to be a row. Okay? It's going to be a row in a table. So here, these are all my databases. I happen to have a music database, right? In Postgres, when I want to connect to a database, right? In Mongo, you went use, right? In Postgres, we go \C, and then you write the name. So I want to use the music database, right? I'm now connected to the database music as user Vagrant. Now, you could also do this when you're connecting to PSQL by going -D. Okay, and if you go PSQL-D and then just write the name of the database, then you're connected to it automatically. Once I'm here, I can start writing some SQL, right? Such as this beast here. Select. Oh no, you know what? Let's do another one. \DT. This is going to be in the notes. \DT lists all of the tables that exist. So I have an albums table, artists, plays, tags, and tracks. I'm going to write select star from artists. Whoa. Got all the artists that I want, right? And I just threw that at you. I went select star from blah, 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 blah. Right? We're getting into these queries. Like the queries that exist are maybe starting off with a create, right? So create is going to look like these things that I was showing you right here. Notice the structure of it ends with a semicolon. Right? Every query has to end with a semicolon. SQL, as far as I'm aware, is not case sensitive. So a lot of SQL looks like screaming. Right? It's just bah. Right? Create table. You can write this stuff in lowercase. It's fine. But for some reason, the standard is that you write this in. Select star from artists. See, that works. And then you could even. This is like. It's like, anybody here? Was anybody here until like the scene thing in high school? Is that no? Oh, you had a grimace. Were you into it? Is that, oh, woo. Okay, this is like that. Like, nobody understands me. Like, that's, you can write SQL like that and it's fine. Okay, it's not case sensitive. You're free to do whatever you want. Okay, you know, wake me up inside. So, you can do that. So we've got our creates. Our database is used to keep track of things. So we need to have these CRUD actions, right? CRUD actions. Create, read, update, and destroy. Here's the create. Insert into some particular thing these values, right? And in fact, let's just do this real quick with beans. I'm going to create a database called coffee. Okay, I went create database coffee, and that's going to be in the notes. create database coffee. When I check all of the databases that exist, there's now a coffee database. When you connect to coffee, right? When I check all the relationships, all the tables, there's none so far. So I'm going to go ahead and I'm going to make one. I'm going to make one with create table beans. Right, create table beans. And now when I go show me all the, tables, like here's all the beans. Now beans, I haven't put anything into it yet, so I'm just going to do one of those insert statements. I'll format this nicely when I give it to you, so it's like cheat sheet style. But it'll be insert into the name of the table that I want to put the thing in, the values that I'm putting in. So beans is going to take, not an ID, or let's just see what happens. I'll go name, roast, and profile. And bean here is going to be, any coffee heads here? What's a bean? Huh? Arabica. Cool. Roast. I'm just going to say light. Light roasts have more caffeine in them. Hot tip. And then profile, coffee. Okay. Never. I'm not like a coffee person. And I could do that insert, right? I just pasted that line in that we wrote. I could do that insert. And now I've got that bean in there, right? I know I left out the ID. We're just going to find out what happens. So insert, create. That's the C part of CRUD. The other thing that I might want to do with data is read, right? And read is done with the all-powerful select statement. All hail the select statement. You're going to spend a lot of time with select. Select, I'm going to write select star from beans. Oh, sick. I guess if I don't write the ID, it just gets automatically generated. Cool. Select star from beans, and what did it give me? All of the beans. All of the beans, right? I mean, I could add another bean in here and say, hey, you know what? Gonna make my own bean. This is a dark roast, and it's gonna be called Nim bean. Right? Just put my own bean in there, and now when I go select star from beans, I've got 2 beans. Right? 2 beans. Now, I've got Arabica, light, coffee. What do you think the star does? What do you think star means? Yeah, select all of what? Right, so I'm going to give you this breakdown of what the select statement is going to look like. A select statement is usually split up into multiple lines because each line kind of does a different thing, and then you end the statement with a semicolon. So we're going to look at some pretty complicated ones in a minute. Select is going to say, starting off, list the data that I want to get. We're going to talk about this in a minute. But list the data that I want to get. So select, I'm going to say, select star from beans. It's going to say, select all of the columns from the beans table. Right, so each one of these queries is always going to return a list of rows, right, or a list of records. Here I'm saying the rows that you return, make sure they have all of the columns that they're supposed to have. Select star from beans. So if I go in here and I say I was to change this to instead select name from beans, I only get the name, right? Select name, comma roast from beans, I get the name and the roast, right? Because I might not want all of the information. Say these are gigantic tables, like monster tables, where you're going to work, your tables are going to have hundreds of thousands, if not millions of records, right? And many, many, many columns, right? They could have dozens and dozens and dozens of columns. We don't want to get all that data back if we only want to show part of it. Right? So we'll ask for some of it. Select just the name and the roast from the beans. Right? So select, it's going to go select the columns from the table that I want to ask for. So list the data that you want to get. From is going to list the tables that I want to get the data from. And then there's a thing called where. And where is going to be used to filter down the rows that I want to get. So I might say something like, hey, select the name and the roast from beans. And then if I'm going to be writing this in multiple lines here, like I could write it all in one line. Select name, roast from beans, where, blah, 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 all in one line. But instead what you'll find yourself doing is not put the semicolon in there. Go on a new line and go where. Because these queries are going to get pretty big. Right? So select name and roast from beans, where roast is light. Right? Where the roast is light. SQL is all about giving you the ability to make these powerful queries, right, with small syntax. Because otherwise in JavaScript, what I might have done was had an array of beans, and then I'd have to go filter, and then for each bean return only the ones where b roast equals like light. Right? SQL just offers us a different way of doing things that have to do with these large clumps of data. Right? I might say where roast is light or where roast is dark. Now I've got nimbean, and nimbean is dark roast. Right? I'm going to hop into our bigger data set, which is the music data set. And you'll select star from, and then let's just see what things there are. Artists, I guess. And go select star from artists. And I've got explosions in the sky. Right. Now, as I keep looking at this, select can also have this thing called group by. And group by says treat a bunch of rows that would have been in the output as a single rows, right? Treat a bunch of rows that would have been in the output as a single row. So, meaning, say I look at, for example, select star from, I did select star from tracks, and I'm getting all the tracks. I'm seeing each track has like an album ID, right? Or and there's repeats, right? So this one here, first breath after coma, the only moment we were alone. These all have the same album ID, right? Or if I was to do select star from albums, I'm gonna see the same thing, right? There are some albums that are made by more than one, but by the same artist. Right, so there's some repeats. So maybe as part of my query, I want to find how many albums a particular artist has made, right? Or find out how many albums each artist has made or something like that. I might do select star from albums and not, let's see, we're going to do select star from albums. I always get stuck when I write SQL, so give me a second here. I've got them down here. Where'd I put it? Where'd you go? There we go. Queries. Okay, so I had things like group by. Okay, wait. I should talk about what join is before I do group by. So we'll work our way through these queries. This thing here says select. and it's saying select title, title, and name, and the particular title is a track title. And this particular title here is an album title. So all of a sudden, we're not talking about just a single table, because if I look at my tracks, there's information from my tracks that also lives, or that's connected to the albums. And if I look at my albums, there's information in the albums that's connected to an artist. So I might want to see all of the tracks and see the artist that made those tracks and see the album that that track's on. If I just do select star from tracks, I don't have that information. So what I need to do is start stitching together information from different tables, right? I know that this here has an album ID, right? I know that a track has an album ID. So what I would like to do is somehow use that album ID, and instead of just having album ID, actually populate it with the album name, right? So I know that the album name lives in the album table. Let me just write this down here. I know that the album ID lives in the album table. So what I can say is say to select both the track title and the album title from the joining of these two tables. So I'm joining together the tracks table and the albums table. And the way that I'm connecting these two things together is through the fact that inside of a track, the album ID should equal the ID of the album in that table, right? And what SQL is going to do is it's going to, for every single one of the star from tracks, for every single one of the tracks that I get back, right, it's going to go through and it's going to replace this thing here, right, with the album name that it finds. So I go ahead and I take this, and what I'm going to find in a second is, and I'll explain, there's some funkiness happening with the syntax, which I'll explain in a sec. Oh, I left a comma in here by accident, which breaks everything. Cool. And now what I got is a bunch of track titles and album titles, right? Track titles and album titles, and that's the join. That information lives in two different tables, but it's been returned mixed together. Now, I'd said earlier that we were going to talk about this word here, duplication, right? Duplication. So what I was doing before was I said, oh, you know what about if we put all the bean information here under the drinks, right? So all the bean information would just be rewritten more than once. What our database would end up looking like on the inside if we did that was like this, right? Except with more columns, where I would see the same thing written out multiple times. And now, when we're talking about databases, right, we want to be mindful of the fact that this is taking up space. This is taking up space on your computer. Besides the fact of that thing that I said where like, oh, what if I change the taste profile? Now I need to go change it everywhere, right? Like that's an issue, right? Since I've duplicated this data everywhere, I need to go find it and change it. But the other thing is, this data takes up space. So each one of these is taking up so much more room than just a number, right? Instead of it being this big string, or instead of it having all the other information, right? I could have replaced all of this with just the number 1, right? And that is what we did when we did when we do this album ID, right? Is this saves space? This saves memory. Cool. So the join is really integral to the relational database model, right? The fact that I can leverage these relationships with join, right? So it goes join on. Join this table here with this other table. Are there any questions about this? Right? Most of your work is going to be dealing with these joins. Right? Most of your work is going to be in figuring out how do I connect this stuff together. Say I wanted to also join the artists in there. I could just toss in another join. Because the artist lives in a different table. So I might say, okay, here is now artists. What did I say? I wanted to see the artist's name. Now you'll notice that if we were to take these tables and stitch them together, just next to each other, some of the tables have columns that have the same name, such as both both album and track. Like albums and tracks both have titles. So if I was to write this, just select title and select title from whatever the resulting table is here, there's this ambiguity about like what does title mean, right? So instead we're going to be renaming our columns. So this is saying, hey, from the track's title, call it title in the output. From the album's title, call it album in the output. I can call this anything. Right? I can call it anything, and if I was to run this, I need to copy that over. Then I get back whatever I said I should name it. Cool. All right, so let's look at a couple more queries here. You can do joins without having to write the word join. You can do that when you say from, if you list out all the tables in with commas. So this thing here is going to do the exact same thing. Right? I can either use the word join, or I can list tracks, comma, albums, comma, artists, and then I'll say where, and I'll have to say that the artist ID needs to equal when it's in the album, and the album ID needs to equal when it's in the tracks. Right? Either of these works, just pick one. I tend to like this a bit more because I like being able to just list out all my stuff like that. Right? But it's really up to you. Right? Again, if I was to run this, I should see the exact same thing. Boop. Title, album, artist. Now, say I want to get all of the artists with their tags. Okay. I don't understand this query. So, like, I genuinely don't. I pulled this from somebody else. I kind of invite anybody to help me understand it. I'm not an SQL person, but we're going to try and dig through it together. This here says select from the artist table the name, and we're going to call that artist. And then also select all of the information for the tags from artists, tags, and artist tags. So it's trying to join through artists, tags, and artist tags, that many-to-many relationship that we had. And it's saying only show me, and this is where I get confused, the as at. So I don't know what that means. I'm pointing this out not to freak you out and be like, oh my god, Nima doesn't know anything. You don't need to write funky queries for your projects, and you'll also be using layers of abstraction over this. I'm saying only show me, oh, AT stands for artist tag. Okay, as AT, where the artist tag's artist ID equals the artist ID, and where the artist tag's tag ID equals the tag's ID. So AT sits right in between artists and tags. It's artist tags. So let's just reiterate through this. It goes select this stuff. So there's going to be one column, and then however many columns tags has. From this. So from the joining of these three tables, where I'm naming artists, tags, and instead of having to write artists tags over and over again, I'm renaming artists tags as AT. And then here are the things that I want to ensure happen. That the artist ID in artists tags is the correct one, and that AT is the correct one as well. The reason I bring this up is because we're going to see in a second when, if we didn't have this where clause, if we didn't have this where, which I'm going to paste in here, you can get something different. So this is that particular query at the moment, and it's showing me all of the tags that each artist has been tagged with. That as AT, that's so I don't need to do this over and over again. Artists tags and artists tags and that. SQL people just get bummed about having to write the same thing over and over again, so they'll make like a short form of it, going as AT. We'll notice like this does the exact same thing. The next part of this query here is saying to select, this is a second query here. It's saying select artist's name as a particular thing, so that's what the column is going to be called. And it's saying something about string aggregate tags dot name. So what string aggregate does is, if I have a group by clause, so if I have a group by clause, I need to say something about how I should be grouping those columns together, right? So if we looked at the beans again, and I said, okay, there's bean Arabica, which is light, right? There's bean Nim bean, which is dark, and then there's other beans, bean A and bean B, which are both one's light and the other one's dark. Say that the thing that I wanted to get back, I wanted to make a query about give me the count of all of the beans that are light and the count of all of the beans that are dark. It means that this information needs to be mushed together somehow, right? That mushing needs to happen, right? Or say I wanted give me a list of all of the beans that are light as a name, like Arabica, comma A, and then all of the beans that are dark also as a list, so Nim bean, comma B. I need to define how does this stuff get smushed. Group by says which of the columns do you choose to smush. right? So I might say group by roasting. So smush all of the ones that match the roast, mush those. In this case here, string ag, that's telling us what to do with that mushing. This one's saying take all of the names and combine them together with a comma. This one here says just count how many things get mushed together. So when I squeeze these together, right, by the roast, there are 2 that have light and 2 that have dark. So if I say count star, it should show me 2 and then 2 because those things got squished that way, right? You're going to see the word folding in the notes that I'll send out, right? How do we fold the stuff into like just having the aggregated information? So if I do this here, and then the rest of this query is the same as the other one, where it's saying join artists tags and artist tags together. Just rename artist tags so that we can do this stuff to filter out the proper things and then group by artist. So if I put this in to PSQL here, right, I didn't get back this post rock and instrumental on 2 different lines for explosions in the sky. I got that stuff back in 1 line because I said aggregate it together, right? And what I also got was a column with the count, right? A column with the count of how many things are in there when it was grouped, right? So SQL is a very rich language for doing that kind of stuff. And now, I hand waved this thing earlier. I hand waved that, and I kind of want to show what's going on if we don't do that. So this was the query that we ran before, the select artist name and the tag information from those things, and there was this where statement. I'm going to remove that where statement and just see what happens. So say I don't have that where. What did I end up with? I ended up with every possible combination of all that information. Like every possible combination of, or is it an artist's name, a tag, and an album. Right. Or sorry, not tag, no. Every possible combination of an artist name, an album title, and a track title. Right? Because I removed that where statement. So where means when you stitched that information together, only return the stuff that matches this. Don't return to me every possible combination, right? Just the combinations that actually matter. Right? This and is because I have 2 things that I want to compare for. Right? Only get me the ones where the artist ID is correct and where the album ID is correct. Right? If I removed this, then I would only get the ones where the artist ID is correct, but the album ID might be wrong, so I got all these like garbage things back. Right? So this and is important in this case. Instead of me getting back all this stuff, right, every possible combination, I should only end up with 11 rows. Does that make sense to everyone? Cool. Here's a couple more queries. Number of albums per artist. I want to select, in my final report, I want to see the artist name, and I'm going to call that column artist. I want to see the number of albums that that person has made, or that artist has made, and I'm going to call that column album count. And this is going to involve me taking the information of all of the albums that artists have made and smushing it. Right? Smushing it so I don't see each individual album, but I see like an aggregation of those albums. Right? So one of my columns is not going to be like album name, it's going to be give me the count of how many album IDs are associated with an artist. I'm getting that on a join from artists to albums, and I'm saying group it by artist ID. So the unique thing that's happening is I'm taking all of the artists, I'm grouping the artists and the albums, right? Like so there might be Kanye and Yeezus, and Kanye and My Beautiful Dark Twisted Fantasy, right? And Kanye and, you know, Life of Pablo, right? Since those three things are associated with the same artist ID, I'm grouping them together and I'm aggregating them. I'm smushing them together. And the way that I'm presenting that in my final report is I'm only showing the count of how many rows got smushed. So here now I end up with some artists have just one album, some other artists have maybe 4. Right? Now, SQL, you might be asking yourself why we don't just write this in JavaScript. SQL is built for these queries, whereas JavaScript is built for dealing with objects and is built with dealing with like these loops and whatever, right? SQL is designed to be asking questions like this, right? On top of that, relational databases are designed to be optimized to give back your like results to your queries incredibly quickly, right? Like super fast. So something that we're going to see this afternoon is I'm going to have like a really big database, like a huge database, and we're going to look at how fast it takes for like a relational database to kind of go through and do stuff, right? Last couple of queries here which are kind of interesting are things like, both of these queries, they do 2 kind of different things, but if I want to see the number of albums per artist, I can show the artist name and the count of how many albums that artist made, but I can also throw in a thing called having. And what having is going to let me do is it's going to let me filter that final report. So whereas I was using maybe, where to filter like my joining, I can also use where to filter my selects. To filter the way that I'm grouping something, I can go group them such that I only want to see the ones where the count is greater than 1. So now instead of seeing God is an astronaut, seatbelts, and rat-a-tat, I only see Daft Punk and explosions in the sky. Because I'm saying, again, after you do the group by, only return the ones where that final count, right? That column that I made here, count artist ID, is greater than 1. I could do the opposite as well. I could say, hey, show me the ones that are less than 2. Now I get back the opposite. Right? This is stuff that you might have done in JavaScript, right? Like it's something that you might have written some code to go through and combine these things, and like I can imagine, I'm sure you can imagine that given enough time you'd be able to write something that does this, right? But SQL is just going to give us this statement here, right? Now, the notes that I give you, I really invite you to like play around with, if you have some time, the database that's in the notes. Loading up the database is done by taking, so the notes that I'm going to give you are going to have this thing here. Where'd it go? Notes that I'm going to give you are going to have the file that I was showing you. And you can run the file by running this command. That's going to load up the database for you. Right? So then you can play with a couple of the queries. Right? It shouldn't take you longer than like 5 minutes just to get it set up and just play. And if you need any help making the thing work, just like I'm right there, come call me up and I'll help you. Right? You can do all sorts of stuff. You can do math. Select the count of distinct track IDs. Right? SQL is a big language. It's a big language. You don't need to use all of it. But say you wanted to do finding the average of a particular thing, right? It's bound to exist in SQL somehow. So as you're working on your midterm projects, I'm just going to take 1 minute to say this. As you're working on your midterm project, come up with questions, right? Such as what we did before, saying, I want to find all of the countries that the beans that Bradlina works with, right? Come up with those questions early. Like, come up with those questions really early, structure your database, right? And before you even start writing any code, I would invite you to start thinking about how you're going to write those queries, right? And then pass it by a mentor or do some Googling to see if those queries can be done in a clever way, such as that. Having track, and I know we don't understand that line yet. That's totally fine. I just want you to play with it, right? But there's a chance that you have to do less work than you think you have to do, right? As long as you do the planning ahead of time and then cross-reference with somebody, right? But start with this step. Cool. Are there any questions? No? So the breakout that we're going to do today is just going to be a little bit more of this stuff. You can, when you group by stuff, you can also order by. And say order it by like ascending or descending of a particular column. The breakout that we're going to do is we're going to look at a big database of like student information, and we're going to do interesting things with it. That's all I can really say. If there's no questions, I guess I'll let you go. I'm going to compile notes. It'll be like 15-20 minutes, and then that stuff will be sent out. Does that sound good? Dope. Have a good rest of the day until 3 when you have to see me again. And then I'm mentoring for the rest of the day as well. Thanks, everyone. Oh, I mean, I guess here's some like interesting info that's not necessarily something you need to know right now. Is I use the word join. Right, I said join and like to stitch databases together. Something that we will talk about during the breakout, I just didn't want to talk about it right now, is that there's different kinds of joins. Right? Right now, just use the word join. Unless the questions ask you to do something different. And then we'll look at that in the breakout. But those notes will be in the notes that I send out right now.